So there you go. Most of these questions are going to be multiple choice questions. I'll be doing the important questions on this exam that I feel students will need for next year and the year after. So here, law of exponents here. So they said 30y to the 8 equals what times 10y squared. So now just deal with the number first. 30 is definitely 10 times 3. We should have a 3 in the question mark there. And then y squared, to become y to the 8, you need to multiply it by y to the 6, because y to the 6 times y squared, you add the exponents, and that will give you 30y to the 8. So 3y to the 6 times 10y squared gives you 30y to the 8. Multiple choice questions, they don't ask you directly. Sometimes you have to work backwards. So you have to really develop a strategy when you're doing multiple choice questions. Question number 3, they say the least common denominator. Okay, so always I tell my students, look at the biggest number. Now ask yourself, does 5 go into this number? Yes. Does 4 go into 10? No, it doesn't. So what you do now, you look at the multiples of 10. So go to the next one, which is 20. Does 5 go into 20? Yes. Does 4 go into 20? Yes. So that's your common denominator, and therefore your answer is A. And here I forgot to choose my answer, and it was C. What's the square root of negative 64? So definitely we have to know all of our perfect squares, the 4, the 9, the 16, the 25, the 36, the 49, the 64, the 81, and the 100. And the list goes on. So basically square root of 64 is 8, but we still have that negative in front, so we keep the negative, and then the square root of 64 is 8, so that's going to be a negative 8. Next is the cube root of 40. So now what you need to know about your perfect cubes. The perfect cubes is, you know, the cube root of 8, you know, the cube root of 27, you know, the cube root of 125, and the list goes on. Now for this, you got to find the number from here that goes into the 40, and obviously it's the cube root of 8. So you could change this to cube root of 8 times the cube root of 5. Now the cube root of 8 gives you 2, because 2 multiplied by itself 3 times gives you 8. But the cube root of 5, you don't know what that is, so you just keep it as cube root of 5. So the answer will be 2 cube root of 5, and we call these mixed radicals. This is entire radicals, and this mixed radicals. So that's what they want you to do here, and the answer would be A right there. Now how about the square root of x to the 4? When you're square rooting something with the exponent, what it does give you, it gives you x to the 2. Basically you half that 4, so it becomes x squared. What I mean here, if you have the square root of x to the 12, for instance, you just go x and half your exponent, which is the x to the 6, and so on. So therefore the square root of x to the 4 is x squared, and D is your answer. So here is another one, negative 1 to the power of 25. Just know if you have a negative number and it's to the power of an odd number, so this is odd, your negative stays negative. And 1 multiplied by itself so many times, it will always give you 1. Plus, now when you square a negative, it becomes positive, so the negative sign is going to become positive. Again, if the exponent outside of the brackets is even, and you have a negative inside the brackets, it always becomes positive, so this here becomes positive. And the 3 squared is 9. So what you're getting is, this is going to be a negative 1 times positive 9, which gives you negative 9 as a final answer, and that's B. Simplify 7 to the power of 3 to the power of 4. Now the rules of exponents, if you have x to the power of a and you have a b outside, the exponent outside of the bracket gets multiplied in the exponent inside the bracket. So this becomes x to the power of a, b. And therefore here, all you need to do is just go 3 times 4, that's 12. So this becomes 7 to the 12, which is C. Now here, 5 cubed over 4 to the negative 7, rewrite with positive exponents. Okay, So here's the rule, okay? If something is on the bottom of a fraction and it has a negative exponent, simply just bring it to the top and make it positive. It doesn't mean though you have to bring 5 to the 3 to the bottom. No, 5 to the 3 has a positive exponent and it's on top, it's comfortable, keep it there. It's 4 to the negative 7, that is a negative exponent. So you take the 4 to the negative 7, since it's negative exponent, you bring it to the top and make it positive, 4 to the 7, and then the relationship multiplication instead of division. Now, the same thing, if you had 3 to the negative 2 over 7 to the negative 3. Now, both of them here, they have negative exponents. So to make the exponent positive, you take this, bring it to the bottom, then it'll become positive. Also take this and bring it to the top, and then it'll become positive. So all you do when you're changing the position of the number that has a negative exponent, whatever has a positive exponent, you don't move it. If it's on the bottom, it stays on the bottom. If it's on the top, stays on the top. So here the 3 comes down and becomes 3 squared. So to just give you another example, if you had, say, 5 to the negative 3, 4 to the 7 like that, then the 5 to the negative 3 will become to the bottom. 4 to the 7 stays in the denominator because it doesn't have a negative exponent. So it doesn't have to change from denominator to numerator, but this have to change, comes from the top, goes to the bottom. And when it comes to the bottom, you have 1 left over. So you don't just write nothing, you write 1 on top, and you still have 4 to the 7 here and 5 cubed. I'm adding a little bit to the questions because I'm trying to get you to understand these concepts a little bit better. So I'll answer the question, and if I needed to elaborate a little bit more, I'll be doing that. Now, the answer for this question here is right there, and that's B. So here's another one. There's a negative exponent on the outside of the brackets. What you do here, you just put the 9 on the bottom, bring the 16 to the top, flip it basically, and when you flip this 16 over 9, then the exponent becomes positive. So that's always the case. If you get anything with a negative exponent outside the bracket, just flip whatever's inside and make the exponent positive. Now, the square root basically means, to the power of half simply means is the square root of 16 over 9. So anytime you see something to the power of a half, it means the square root. Now, if you're square rooting a fraction, lots of students, they get stuck on this. Just look at those numbers both separately. So now the square root of 16 is 4, which is on top, and the square root of 9 is 3, which is on the bottom, and that's your answer. So that's D. Now, how about here? 0.03 to the negative 1. The first thing you want to do here, if you cannot use the calculator, is to change this to 3 over 100, because this is the 100th decimal. So it's 3 over 100 to the power of negative 1. Now, again, the same thing as here. If we have a negative exponent, we could just flip over 3 all to the power of 1. When it's to the power of 1, we don't write it. So that's your answer, which is 100 over 3, and that's E. So here's one. Here, my advice to you is when you have an exponent outside the brackets, distribute it into the exponents inside the brackets. You don't only distribute it to the top, you distribute it to the bottom as well. So this will become 3 to the power of 3, and on the bottom, negative 3 times negative 2 is 3 to the 6. So that makes the exponents positive, so you don't have to do anything more than that. Now, what I do here, I reduce, okay? So I say 3 to the power of 3 goes into itself once, and 3 to the power of 3 goes into 3 to the 6, 3 to the power of 3 times, which gives you eventually 1 over 3 to the power of 3, and 3 to the power of 3 is 27, so you could just go 1 over 27, which is C. Now, some of you maybe who don't like doing it that way, you could also go, okay, 3 to the power of 3, 3 to the power of 6. I know I was taught if I'm dividing, I minus the exponent. So this will give me 3 to the power of 3 minus 6 will give me negative 3. Now, since this is a negative exponent, we flip, everything is over 1. So bring the 3 to the negative 3 to the bottom and make the exponent positive. So that becomes 1 over 3 to the 3, which gives you 1 over 27. So this or this, I think most likely some students will find this a bit easier. If you're able to do that, do it as well. But this is again another way of doing it, and so you have the choice. In math, I always say to my students, you don't have to follow a certain way. As long as what you're doing is logical and it doesn't defy the rules of mathematics and you're getting to the answer, just do it. If that's the way you understand things, do them that way. Okay, which of the following is equivalent to x to the 5? So x to the 5, I gotta find something when I do the operations, it gives me x to the 5. So I'm just gonna have to work through all of these. So now when you're dividing here, you minus the exponents, and x to the 15 divided by x to the 10. So 15 minus 10 is x to the 5. Hey, the first one is the right answer. So I don't even have to do the other ones. If you want me to go over the other ones, this is x to the 30, x to the 6. So you know your minus the exponents is gonna be x to the 24. This is 5 times x to the 1, it gives you 5x right here. This will give you something that what we did in here, x to the 5 times x, it gives you x to the 6. Remember, you're adding exponents when you're multiplying, and this has a 1 that we don't write, so that's x to the 6, but the answer is this one. How about here? 8 to the 12x divided by 8 to the negative 2x. That becomes 8. When you're dividing, you minus the exponents. So basically what you're doing, you're taking 12x minusing negative 2x, which becomes 12x plus 2x, 14x, and therefore this gives me 8 to the power of 14x. So basically you're just not minusing exponents. If you don't want to go through all of this, 12x minus negative 2x, it becomes 12x plus 2x, so 18 to the power of 4x, and 8, sorry, that's 8 to the power of 14x. And that's your answer right there. So here again, we will continue. So now we have x to the 4 plus x to the 5 added. We cannot add them because they're not like terms. You remember, we can only add variables when they have the same exponents. So since this is x to the 4 and this is x to the 5, we cannot add them. So what you could do, you could change this to x to the 4 over x to the 4 plus x to the 5 over x to the 4. Because this is a common denominator, I could split it with this plus this. So that's what we did there. X to the 4 divided by x to the 4. When you divide anything by itself, you always get 1. And x to the 5 divided by x to the 4, you just minus the exponents and you get x to the 1. We don't have to write the 1 on top. And the answer here is A. Now write in radical form. So this is the rule for changing exponential to radical. So if you have x to the power of A over B, you change that to the B root of x to the A. So this bottom here becomes the root and A becomes the power. Okay, so therefore this will be 6. You put that. A is representing 4 right there. And sorry, A is representing 4 and 5 is representing B. So 5 will be here and 4 will be right there. And the answer will be right there. Now this one, evaluate. So they want you to evaluate. The first thing here, we have a negative exponent. So we have to change that to 1 over 16 to the power of 5/4, and which gives me 1 over, and now I change this to radical, so it's the 4th root of 16 to the 5. Now if you do the 4th root of 16 is the number that when you multiply it by itself 4 times, you get 16, so it's 2, because 2 to the power of 4 is 16, so the 4th root of 16 is 2, but you still have the 5 there, and then 1 over 2 to the power of 5, just multiply 2 by itself 5 times, and that will give you a 32. Also, there are buttons on your calculator that will do that for you as well, and you could use the calculator doing this stuff as well. Okay, but understand what's behind before you use the calculator, understand what you're doing. Next. So here another one that is 32 to the negative 0.8. So I think what we do, we'll take the 0.8 here and change it to negative 8 over 10. And that will give me negative 4 over 5. And therefore, this becomes 32 to the power of negative 4 over 5, which means it's 1 over, because we want to get rid of the negative exponent, 32 to the 4 over 5, which gives me 1 over the 5th root of 32 to the power of 4, which equals 1 over the 5th root of 32 gives you 2, and that's 2 to the power of 4, and therefore this 1 over 16. If you're allowed to use the calculator, then you just go 1 over, and then you take the 32, raise it to the power of, and put the 4 over 5 inside the brackets like this, and it will give you 1 over 16 as well if you're allowed to use the calculator to do this. Okay. How about here, simplify? So now, to simplify this, first of all, I'm gonna square everything. And if you wanna square everything here, you just square the stuff on the inside. So I'm gonna keep it as the 4th root of a to the 10 and b to the 6. Now I'm gonna change this from exponential, from radical form to exponential form. That's what they're doing. So we're doing the opposite. And therefore this becomes a to the 10 over 4 and b to the 6 over 4. You remember, if we have radical form b x to the a, then you could change it to x to the power of a over b. So that just goes right there as we did in here. Now reduce, that's a to the 5 over 2, b to the 3 over 2 when you reduce the 6 over 4 as well. And therefore, this is b is the answer. Here they say add. So 9 plus 2 is 11. And this becomes 11c cubed. You add them because they're like terms and they align them with their like terms. Negative 4 plus 4 is 0. So there's nothing there. And c plus negative c, that also cancels. So these will cancel because they have opposite signs and they're the same thing. And negative 6 minus 1. So negative 6 plus negative 1, it just gives you negative 7. And this here is 11c cubed minus 7, which is c. So here is algebra now. They want you to simplify this. So we use the distributive property. We put the negative 3 right through here and right through there. Negative 3 times x is just negative 3x. Negative 3 times negative 2 gives you positive 6. So just multiplying negative times negative is positive. 3 times 2 is 6. And then you still have plus 10 there. There's no need for the brackets anymore because the bracket just means, the brackets just mean you're multiplying the negative 3 inside here. And now you collect like terms. So you still have negative 3x, positive 6, plus 10 is just plus 16. And therefore your answer is C. How about here? Distributive property again. So 6 times 4x is just 24x. 6 times negative 2y, just minus 12y. And then we still have the minus 40x there. These are like terms. So now I go 24 jump minus 40x, and that's going to give me negative 16x, and minus 12y will just stay as minus 12y. So negative 16x minus 12y is right there. Now here, expanding binomials. So this is, we call this foiling. So you multiply this first into the first, and here you multiply this into here. And after you finish with that, you go this times this and this times this. So that's the order. So a times a is a squared. A times negative 3 is minus 3a. 4 times a is plus 4a. 4 times negative 3 is minus 12. Always collect like terms. So you have a squared minus plus 1a. So you don't have to write the 1 minus 12 because negative 3 plus 4 is 1. So a squared plus a minus 12. The answer is D. So how about expanding 3x minus 8y squared? Lots of students make this mistake. They square this and they make it 9x squared. And then they say negative is squared is plus, and then 8y squared just becomes 64y squared. Don't do that. That's wrong. So anything when it's squared, it means it's multiplied by itself. So I'm just going to write it here. So it means 3x minus 8y times 3x minus 8y. That's what it means. So it means you have to FOIL again here, and then there and there. And therefore, that's give you 9x squared. 3x times negative 8y, it gives me negative 24xy. And again, that will give me negative 24xy again. And negative 8y times negative 8y is plus 64y squared. Collect like terms. So this will give me 9x squared minus 24 is minus 48 xy, because they're like terms, these ones right here. And then plus 64y squared. Here, you're foiling, except now you have a binomial here and a trinomial there, means 2 terms here and 3 terms here. The same thing, you just gotta be a little bit longer. So here and then there and then here, and then the same thing here and then there and then there. So now x times x squared is x cubed, x times minus 3x is minus 3x squared, x times negative 6 is just negative 6x, and now negative 5 times x squared is minus 5x squared, minus 5 times 3x is plus 15x, because it's a sign, a negative times negative is positive. And then negative 5 times negative 6 plus 30 equals, collect like terms. I think here where x times, x times negative 3x is negative 3x squared here. Just forget to write the square here. So therefore, we only have 1x cubed. These are like terms. So negative 3 minus 5 is negative 8x squared. And these are like terms right here. So negative 6 plus 15 is plus 9x. And then we still have the plus 30 at the end. Okay, this is the last question that we will do. So here, I'll leave this for next time. My time is running out and I have to run to coach soccer. But thanks for watching. Don't forget, like my videos, subscribe. I'll be putting a lot of good stuff on, and share with others so they could benefit. This stuff is so important for your kids to understand. As soon as they go to grade 11, they have to have solid foundation with the material that we're doing right now, because all math 11 and 12 depend on this. So I hope your kids enjoy watching this. Thank you for watching. Bye-bye.